I'm Stephen Foskett, and I'm going to talk a little bit about some of the emerging storage technology that we're seeing in the marketplace right now. I'm a writer and blogger and speaker at enterprise storage industry events, and I've been doing this for a long time, long enough to see a lot of innovation in the enterprise storage space. We're lucky now in 2013 to be seeing just a massive innovation. There are many, many exciting new companies with innovative products coming out. And it's interesting for me to watch the market and see how things evolve, because you see certain patterns and trends emerging. And there are basically waves and waves of ideas that come out of the industry in response to shortcomings of existing technology. I'm going to start with a little history of enterprise storage to set the stage for what I'm going to talk about later. Many people are familiar with the concept of RAID, where you take multiple disk drives and combine them to make them reliable, to give them better performance, and to create basically a single virtual hard drive that can be used for applications. This is the foundation of the enterprise storage industry, and every enterprise storage product since the 80s has been based on RAID technology. That was the beginning of the enterprise storage industry, and RAID remains the bedrock foundation of many, many enterprise storage products. But that's not necessarily the only way to present storage. Now, most storage arrays are what we call block storage arrays that use SAN protocols like iSCSI or Fiber Channel. These basically present a fake hard drive to the attached servers. So the server believes that it's talking to a simple internal drive, and it runs a file system on that and does whatever it is that the system does. This is great for applications because applications are not designed to work at a higher level. They're really designed to just write to a file system and do what they do. It's also a very basic construct. There's not a lot of layers in between, and it allows the storage to just work with an application. The problem is that a lot of this technology is not all that flexible and not all that scalable. And scalability is one of the biggest challenges in any kind of enterprise IT, but especially in enterprise storage. For that reason, a number of companies came out with what they call NAS, or file servers. And what these are is a different type of thing than SAN or block storage. With NAS, what you get is a file system that presents files across a network. NAS systems generally can share a file system much, much more broadly than a Fiber Channel or iSCSI SAN. And since it's a higher level of abstraction, that means that they have traditionally had many advanced features, including snapshots and replication and things like that. These have become really the primary location of the bulk of data in many, many businesses. So what we have here is two different types of storage. We have, on the one hand, RAID, SAN, and block storage that supports applications. And on the other hand, we have Windows file servers running a protocol called CIFS or SMB that support users and files and groups. And these two areas have both progressed, but somewhat diverged. And what we see in the industry is a great deal of divergence of focus in each of those areas. So on the one hand, a lot of the emerging technologies in the block storage space focus on performance, and specifically random I/O performance. On the flip side, on the NAS side, many of the emerging products and technologies focus on capacity, because as everyone knows, there's just massive, massive growth in the amount of data that businesses have to deal with. Even individuals have many terabytes of data today, and that was unheard of. I mean, there literally weren't terabyte-sized storage devices a few years ago. One of the buzzwords in the industry right now is what they call big data. And let me just explain that for a minute. Big data simply means data that's too big for conventional systems to handle. And it could be big in terms of performance, as I was mentioning with I/O performance. It could also be big just in terms of scale. Again, a petabyte is just an incredibly large amount of data. Many applications have difficulty accessing that much data, and many storage systems have extreme difficulty growing to that size. even many tens or hundreds of terabytes is beyond the range of many storage systems to grow. Now, of course, not every business needs this. For every Google or Facebook or somebody with just a tremendous capacity need, there are literally thousands and thousands of mid-market companies, and they have big data too. It's just not quite that big. Their big data needs may be bigger than the capacity of a conventional storage array, but they're not necessarily growing into the exabyte scale. And again, if you've got this kind of need where you find yourself having many terabytes of data and rapid data growth, which is really the case with many mid-market companies as well as those big famous data users, you find yourself running up against the limits of whatever storage system you buy. That's because it's really difficult to make a storage system grow. It's fairly easy to take a storage system and grow it from 1 to 2 or from 1 to 5, now whatever the number is. In other words, it's easy in many cases to double the capacity of a storage system. It's very hard to grow storage systems by 10 times their initial size or more than that. And the reason is that technologies like RAID and the traditional underlying architecture of these storage arrays with a single controller and shelves of disks and so on, they just weren't designed to scale like that. And in fact, this is one of the primary challenges that everyone in the industry faces, especially the big incumbent storage device providers. They have these architectures that, yes, they can scale, but they can't scale flexibly. They can't scale linearly. They have to buy, basically you have to buy a really big chunk of data at a time, or you have to go out there and pull out the old one and put in a new one. And this really doesn't meet the needs of people who are trying to run these environments because, of course, you don't want to have a downtime in order to swap out storage systems. You don't want to have to go out there and spend 200 or 300% of what you spent last time in one go. That's really hard to do. So everyone is in the industry, all the storage companies are trying to figure out how to tackle this problem. Interestingly enough, this problem has already been solved. Again, if we go back to those really famous, big data users, the big internet sites, they don't use anything like conventional storage. What they do is something entirely different. They have a much more abstracted storage system based on objects. So instead of blocks like a SAN storage array or files like a file server or NAS, they base it on an object. And an object is really just an arbitrary chunk of data. What this means is they have a higher level abstraction, which means that they can have a sort of a translation layer that decides where data goes. And this means that they can build a system that scales, not just massively. Now, of course, these devices, these systems scale just to tremendous size. Most people have heard of Amazon S3, for example. This is a cloud storage service that Amazon originally built for their own use and now allows businesses and even individuals to use. Amazon S3 is not NAS or block storage. It's object storage. It's cloud storage. And what they have is basically a massive set of independent storage nodes. They break up I/O into these objects. They decide which object goes where. That allows them to scale to just massive proportions, but it also allows them to do something pretty neat, which is to scale slowly. In other words, if you have, 1 unit of storage, you can add a second unit of storage, or a third, or a fifth, or a 13th, or a 58th. And each time you're adding just a little bit of a stair step of storage, which means that instead of replacing the entire system with a bigger system, or instead of buying another giant system and trying to integrate them, it just grows, and it grows according to need. And this is really fundamental to the whole world of cloud storage. And a lot of this technology is now coming down to business use. So you may not want to store your data in a public cloud like Amazon alongside everybody else's data. But businesses take a look at this and they say, I have storage needs that are outgrowing the ability of an older storage array. I would like to be able to scale as I grow instead of buying just a giant chunk or ripping and replacing everything. I want some of that. The problem is that object storage and cloud storage isn't directly accessible by today's applications. This is one of the things that's really holding back the adoption of something like Amazon in the enterprise. You look at it and you say, this makes a lot of sense to me. And then you look at the needs of your applications and you realize, well, none of my applications can actually use this storage. So I guess I can't do it. I guess I can't adopt this. This led to the rise of basically a translation layer, a gateway, some way to allow conventional applications and clients to access cloud and object storage in a simple way. This allows them to get the benefits of massive scalability, of growth, without having to rewrite applications or find totally new applications. It basically opens up the world of object and cloud storage to businesses. The value of cloud and object storage, though, is not necessarily only in the ability to scale. There are all sorts of other wonderful things that you can do once you've moved to this object and cloud world. And that's really, to me, the most important thing. I don't doubt that eventually all the big guys will figure out some way of making their storage systems scale. It's going to be a challenge. It's going to take a lot of development. It's going to be very hard for them to do that. But eventually, hopefully, they'll figure out how to do that. It's going to be much more difficult for them to add features to these legacy systems because they have to start really back in the 1980s with RAID, and they have to figure out how they're going to have multiple RAID sets and how they're going to combine those and all this sort of thing. They're basically building a stack on extremely old technology. What they should do instead, and what's really a better technical solution, is to have a totally different storage architecture, one based on objects like the cloud storage providers, and build out features on objects. So you get scale, but you also are able then to take those objects and do really nifty things with them. So for example, object and cloud storage systems can create multiple copies of an object. So I write, once and it stores it 2 times, 3 times, 12 times. You can store copies in different locations. So I write once and it stores a couple copies here and a couple copies across the continent. And that can be, asynchronous. So it's not like the old storage replication where you had to worry about, waiting for it to complete, things like that. You can just have it go behind the scenes. You can also easily do snapshots, meaning however the file system or the object store looks today, I want you to just save a reference to all those objects. And then I want you to continue reading and writing. But if I ever want to go back to that point in time, I'll just go back to the reference instead of trying to literally save a copy of all that data as it was. This gives you the ability to do what they call continuous data protection, which means why don't I just save every object state, or at least a lot of object states, so that I can, kind of turn the dial back in time. A lot of people are familiar with, sort of the Apple time machine idea, where you can literally kind of go back in time and see, well, how did it look, at 12 o'clock? Okay, well, how did it look at 11 o'clock? How did it look at 10 o'clock? And all of this is made much, much more practical by using this sort of object storage technology. Object storage also gives you the ability to deduplicate data, which is a really, really clever trick where you look at incoming data and you say, well, I've already stored this once before, so I'm not going to store another copy of it. Instead, I'm just going to create a new pointer to whatever that object is. And since the gateway generally breaks up a file into many, many little objects, little chunks of data, you can even do that inside a file, which gives you just tremendous capacity gains. You can encrypt objects, you can compress objects, you can do all sorts of things. I mean, basically, an object storage system gives you a lot of opportunities to juggle your data around in a way that RAID, simple RAID storage array just never could. And, this is really the direction that pretty much all modern storage systems are heading. As you can see, there are a lot of really exciting technology options when it comes to object and cloud storage and gateways and dedupe and replication. And companies are in a position where they can really go wild. They can build a completely custom system that they really have integrated into their applications. But not everybody wants to do that, especially when it comes to mid-sized businesses and businesses that are not in the IT space. They don't want to design and build their own storage system. They don't want to have all that complexity of engineering a system. They actually just want something that works. They want a big file server that grows as they need it and keeps their data safe. And for those folks, they've really found a challenge, honestly, in how storage systems are managed. Traditionally, when I started, storage systems were managed on a system-by-system basis. You'd literally plug into the back of the system. Now, most of them are managed over the network, but you're still using a proprietary management application, a different application per device. Each one has its own quirks and tricks, and you need to install whatever flash or something on your laptop in order to use it. It's actually kind of a nightmare to try to manage a lot of these things. For that reason, a lot of management, IT systems management, and this goes beyond the storage space, a lot of management is moving into the cloud and the web as well. The idea being that you can have a simple web-based management application that runs in any web browser that manages the device remotely. So instead of going in the data center and plugging into things and trying to install an application to manage a specific system, you can just open a web browser. You can point it to a certain site, you can authenticate in a certain way, and this gives you a lot of flexibility. The company also has a lot of opportunity to innovate there to make management even easier. Just putting something in the web doesn't make it easy. But if you focus on ease of use and ease of management as a provider, you can really come up with a really simple management system. There's no reason, for example, that end users have to muck around with manual settings for replication and encryption and all that. I mean, they should just be able to check a box. There's no reason that they should have to spend a lot of time, partitioning and dividing things up. They can just, drag something or type in a number somewhere or something. So it's going to be interesting to see where companies go in terms of making web-based management easily and available. But I think it's pretty safe to say that the days of proprietary management applications are numbered. So again, to sum up, we started with a very, very simple idea. Take multiple disk drives and combine them into one using RAID. And out of that, a whole industry grew of shared storage over SAN, of file systems shared over NAS, of object systems that span, massive scale and multiple locations and live out in the cloud. We've got gateways that allow those cloud and object storage systems to be accessed as if they were just plain old file systems. But underneath the covers, there's a whole flowering of new ideas of ways to manipulate data in those object storage systems that really are giving much more value beyond just the simple question of how big does it get and how do I get there? Thanks for watching this video on emerging storage technologies. Once again, I'm Stephen Foskett. You can find me online at blog.fosketts.net. I also run the Tech Field Day event series. You can find that at techfieldday.com. And you can find me on Twitter at @sfoskett.